Okay, students. So yesterday we were studying about fault. Okay. So what do you mean by fault? This is a fault. Okay. That means so it's very important to understand the difference between a fault, and third one more topic is the joint. Okay. So this is a fault. Okay. So we have studied what you mean by a fault, and then we have studied different parts of a fault. Okay, different parts of a fault we have studied. After that, we have studied the classification of the fault. Okay, how we are classifying faults. Okay, so mainly it is classified around four criteria. Okay, which are those four criteria? First one is based on the relative movement of the blocks. Second one is based on the relationship between the dip and strike of beds. Third one is based on the slips, and fourth one is mode of occurrence. Okay, so attitude means dip and strike. Okay, dip and strike collectively it is called as attitude. So we have discussed all those things. Now it's very last one. Okay, so this is a fault. Okay, this is a false. So next one is the causes. What are the reasons that is actually causing a fault? Okay, so we have already discussed about this. Okay, so fault is actually caused by tectonic forces. That is the force that is occurring below the earth. Tectonic, non-tectonic forces, all these things we have studied in the second module. So I'm not going to explain that in detail. So anyway, understand that the faults are caused by tectonic forces. Okay, so faults develop due to failure of the rocks against shear stress. Okay, so because of the shear failure, the faults are occurring. Okay, now, there are some fault called as gravity faults that is occurring due to the horizontal tensional forces. Okay, that is like your landslides. Okay, example is your landslide that is horizontal because of the horizontal tensional forces. For example, landslide, gravity faults are also formed. Okay, now thrust forces are developed due to compressive forces. Okay, because of the compressive forces that is occurring in the rocks, we can also expect the faults to happen. Okay, so how faults are occurring? Faults are occurring mainly due to tectonic forces, then due to shear failure of the rocks, then due to the horizontal tensional forces that is occurring, and also due to the compressive forces that is developed inside the rocks. Okay, so because of all these reasons, you can expect a fault to occur. Now, what is the importance of a fault? Why you are studying in engineering aspect? Okay, why we are studying a fault, the engineering consideration of a rock. Okay, so fault can cause a shearing and crushing of the rocks located in the fault zone, making the rock weak on one hand, porous, permeable, and other hand. So what is happening in a fault? In fault means it is actually crushing and shearing of rock is occurring. From this picture, you can see the picture. Okay, so in this picture, it is pretty clear, right? Here, what is actually happening? Here, the rock is getting crushed and sheared. Okay, due to the forces that is acting inside the rocks, the rock is getting crushed and sheared. So thereby what is happening? The rock is becoming permeable and porous. That means it will allow, if there is a crack like this, it will allow the water to pass through it. Okay, so thereby the rock is becoming permeable and porous. Okay, that means it is becoming a weak rock. So there how we can say that the fault lead to the formation of a weak rock. Okay? So in the engineering aspect, we need to see the importance. First one is the faulted rocks will form a weak foundation for the dams. Okay. So wherever the rock is faulted, such site cannot be chosen for a dams. Why? Because the dams they need a very good strong foundation. Okay, dams means mainly we know that it is meant to carry the hydraulic force, the water tons and tons of water is stored in dams. So it is meant to carry a huge amount of hydraulic forces. Okay, so there the foundation has to be very rock, very strong. So here the rock is faulted. See, if the rock is faulted like this, it will not be able to take a huge amount of load. So such sites cannot be chosen for dams. Fault zones will provide easy pathways for the water and causes leakage when left untreated in the dams. Definitely. So if you are choosing such sites for the dam, what will happen? The water will seep down. That means the rock is actually permeable. The faulted rock is permeable. It will allow the water to pass through it. So if you are constructing a dam over it, what will happen? The water will pass through this crack, and thereby it will again weaken the dams. Okay, so once the fault zones becomes lubricated with the water, the probability of further slipping becomes high, and this create a critical condition within the foundation. Okay, see, so once the water is passing through these cracks, once the water started passing through this crack, what will happen? Eventually the rock will become big. Okay, with the passage of the time, the rock will become big, and there is a chance that this rock may again get crushed. Okay, there is a chance that the rock may again get crushed. Okay, so we can never ever allow such rocks meant to carry a high load. Okay, it cannot be chosen for a massive structure construction. So another important thing is that, okay, see, sorry. So that is once a fault has lubricated with the water, that's it. So this may create a critical condition within the foundation. So slipping can occur. So we should always avoid such sites. Next one is faulting products like gauge and brescia create additional problems. Okay. So gauge and brescia, please note these two words. Okay. Uh, okay, whatever it is. So gauge and brescia. I'll show you what is gauge and brescia. So gauge and brescia, these are actually results of fault. So gauge means basically that a rock powder. See here, this is a rock which has subjected to a fault. Okay, so fault has occurred in this rock. So once the fault has occurred, you can see some rock powder. Okay, so this rock powder is called as gauge. The rock powder is called as അത് പാറകൾ പൊടിഞ്ഞു പോവുക ചെയ്യുന്നത് പാറ പൊട്ടി പോകുമ്പോൾ പാറപ്പൊടി. So that is a rock powder. So that is called as gauge, and rock fragments that is found is called as breccia. Okay, rock in the fault plains. Okay, പാറപ്പൊടികളും കുറച്ച് പാറന്റെ കുറെ കെട്ടുകളൊക്കെ അവിടെ ഉണ്ടാവും. Okay, so rock fragments that is found in the fault plane is called as breccia. Okay, so these two rock gauge and breccia are the strong evidence of faulting, and which shows that there is a high chance the rock will be sheared. Okay, അല്ലെങ്കിൽ റോക്ക് ക്രാക്കിന്റെ അല്ലെങ്കിൽ റോക്ക് ഷിയറിന്റെ വെരി ഗുഡ് എക്സാമ്പിൾസ് ആണ് ബ്രസിയ ആൻഡ് ഫോർച്ച്. Okay, so you have to take care about these two things. Okay, brescia and gauge. Okay, these are the two important things that you have to note, because പാറകൾ ഇങ്ങനെ പൊടി പൊടി ആയിക്കൊണ്ടിരിക്കുകയാണ്. അതിന്റെ ഏറ്റവും വലിയ എക്സാമ്പിൾ ആണ് ഗോജ് ആൻഡ് ബ്രസിയ. Okay, so gauge and brescia are the two best example, or you can say two best faulting products, which shows how weak the rock is. Okay, so same thing here. So next one is joints. Okay, joints. Now what do you mean by joints? So we have studied about the fault. So what do you mean by fault? This is a fault. Next is we have studied about fault. This is a fault. Next thing we are going to study about joints in a rock. Okay, so what do you mean by joints? So joints are basically, these are the cracks or fractures that divides a rocks into a number of parts, and there will not be any relative displacement between these parts. Okay, so basically joints means what? What do you mean by two joints? Joints means when two bodies are joined together. Okay. So similarly here also, joints means they are actually cracks or fractures that are actually dividing rock into different blocks. But there will not be any displacement between these two blocks. Okay, there will not be any displacement between these two rocks. So such parts are called as joints. Okay, so this joints occurs in all types of rocks. It is like cleavage that you see in the mineral. See, these are all joints. Okay, that you are actually seeing is a rock joints. So this is actually this is a crack. Okay, these are a cracks or fractures, but you can see that there is no distance between these two parts. There is no distance between these two parts. Am I clear? Am I clear? See, if you take this is a crack. Okay, so this is one rock part, this is another part of the rock. There is no distance between this rock and this rock. Okay, see, like this is one rock, this is another rock. Imagine like this. Okay, rock 1 and rock 2. Okay, there is no here there is no displacement. Okay, I'm going to color it. You can see that there is no distance between these two rocks, or you can say no displacement between these two rocks. So such parts, okay, or such cracks or fissures are called as joints. Okay, so joints basically they are the cracks or fissures that divides a rock into a number of blocks, but there won't be any displacement between these two blocks. Here also I can say there will be one more joint like this. So this is two. These are the two blocks of rock, but you cannot see any displacement between these two rocks. Okay, so that is joint. So try to understand the difference between these three things. These are very important. You can expect definitely for the university: fold, folds, and joints. Okay, so coming to the terminologies that is related to joints. Joints are basically fractures along which there is no displacement of the blocks. Okay, so joints means basically they are fractures. So if you say this as a rock mass, you can see a fracture like this. Okay, so this is a fracture and there is no displacement. So this fracture has divided this rock body into two blocks. This is first block and second block, and there is no displacement between these two blocks. So this is called as a joint. So joint are the fractures along which there is no displacement of the block. Joint plane means the plane in a rock along which there is a fracturing. So the along the so this plane, so this is here, this is the plane along which the fracturing has occurred. So you can say that this is a joint plane. The plane along which the fracturing has occurred is called as a joint plane. Dip and strike of the joints. Okay, dip means what? Basically it is an angle. We have studied dip means angle. Okay, so dip is an angle that joint plane make with the horizontal. Okay, so if this is a, imagine this is a joint plane. Okay, so the angle that joint plane is making with the horizontal plane. So if here, if this is the horizontal plane, here if this is the horizontal plane, angle that the joint plane making with the horizontal is called as dip. Okay, so what do you mean by dip? Dip is an angle that joint plane, this is the joint plane over here, the joint plane make with the horizontal is called as dip. Strike is a direction of intersection between the joint plane and imaginary horizontal plane. Okay, so strike means what? Same like before, it is the direction of intersection. Okay, so it is a direction this. Okay, direction of intersection between the joint plane and the horizontal plane. Same like before, there is no difference. Okay, likewise we studied in fold and folds, same thing here, only the plane has been changed. Okay, okay. Now the fractures divide the rocks into parts unlike faults, and these parts have not suffered any movement along the fracture plane. Okay, so there won't be any, the fracture will occur, but there won't be any movement. Okay, so mainly there are three types of joints. First one is open and closed joints. Open joint means the blocks have opened up for a small distance. Closed means there is no separation, but it may be capable of allowing fluids to pass through it. Okay, I'll show you a picture of this. See this picture. Okay, so you can see you can refer the first picture now. Okay, so it's the first picture. So here open and closed. So open means what? The blocks have opened up for a small distance. That is the blocks, the two blocks. This is an open block. Okay, this what you're seeing is an open block. That is here the blocks have been opened up for a very small distance. Okay, it has been opened for a very small distance. So such things or such joints are called as open blocks. Closed means there is no separation, but it will allow the water to pass through it. See this one. This is a closed one. Okay, this is a closed one. So here you can see that a joint or a fracture has occurred in the rock, and this is not allowing, there is no distance between these two blocks, and sorry, but this will allow water to pass through it. Okay, there is a fracture in the rock. Okay, there is a fracture in this rock, there is no displacement or there is no movement, but this fracture will allow the water to pass through this, the water will pass through. Okay, next one is smooth and rough joints. As the name indicates, you can see the picture J3 and JT3 and JC4. Okay, that means, see here it is a smooth one, here it is somewhat rough joint. Okay, so that is along, if it is along a smooth surface it can call as smooth joint, and if there is some roughness you can see here. Okay, some roughness, some corrugations has occurred, so that is a rough joint. Okay, next is small and master joint. This is not much important, I'm just telling you. Okay, you have to study about only open and closed. Okay, the next one is small and master joints. Master means most prominent extensive joints is called as master joint. That means if it is a continuous joint. Okay, if it is a continuous joint, it is called as master joints. See, if you can see here, this is a continuous joints. Okay, so this continuous joints are called as master joints, and discontinuous joints are called as small joints. Okay, so if the joint is going continuous, it is called as master joints. Small joints. Okay, this type of this type of joints is called as, which are discontinuous is called as small joints. Okay, that's it. Okay. Okay. Now, coming to the next one, based on the classification of the joint. Okay, this is very important. We have to study the classification of the joints. So it is mainly classified based on three criteria. First one is spatial relationship, geometry, and genesis. First one is spatial relationship. Based on the spatial relationship, it is classified to systematic or regular joints. Okay, so systematic means systematic and non-systematic. We can study combine. Okay, systematic means it will show a distant regularity in their occurrence. Okay, like this. So this is a systematic joints. You can see here a systematic joint. These two are systematic joints. Okay, so joints which will show a regular pattern, like a column or like a mural joints. Okay, it will show a systematic pattern like this. Okay, so what will be non-systematic? Okay, non-systematic will be irregular in pattern. Okay, irregular in pattern. That means it does not have any regularity in their occurrence. It does not have any regularity in their occurrence. This is non-systematic. You can see here. See, this is non-systematic. Okay, like this. It will occur like this, like this, like this, like this. Okay, that is based on the occurrence. Okay, systematic എന്ന് പറഞ്ഞാൽ it will be like a very well pattern, a very good pattern. It will show a very good distinct pattern, like a columns or mural joints, etc. Okay, non-systematic means it will be irregular. Okay, it will be having irregular pattern. Okay, that is systematic joints and non-systematic joints. Okay, systematic joints is also called as regular joints. Non-systematic joints is also called as irregular joints. Okay, sorry. So next one is based on the geometry. Okay, so based on the geometry, it is classified as, first one is stratified rocks. We have studied about stratified rock. What do you mean by stratified rocks? That is layer by layer. Not sorry, 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 not sorry. Not stratified rocks. Based on the geometry, in the stratified rock, you can see strike joints, deep joints, and oblique joints. Okay, so here this is a stratified rocks. Okay, so stratified rocks means the rocks which are deposited layer by layer by strata. Okay, like this. There will be one layer, another layer, another layer, another layer. Okay, so this arrangement of bed of the rock is called as strata. Okay, so when this is called as bed of the rock. Okay, this is called as the bed of the rock, and if this bed of the rock is arranged layer by layer, it is called as stratified rock. Layer ആയിട്ട് ബെഡ് അറേഞ്ച് ചെയ്ത് കഴിഞ്ഞാൽ അതിനെ സ്ട്രാറ്റിഫൈഡ് റോക്സ് എന്നാണ് പറയുക. Okay, so it is having a parallel arrangement. Stratified rock means it will have a parallel arrangement. Okay, now in the stratified rock you can see strike joint, dip joint, and oblique joint. Okay, so what do you mean by strike joint? What do you mean by dip joint? What do you mean by oblique joint? Can you tell me what is a strike joint? Okay, so you can see from this picture, this is a strike joint, that is which is occurring along this line of intersection, like this. This is a strike joint. Okay, dip, that is an inclination with the horizontal, that is dip joints. Oblique means this one. Okay, joints which are inclined at an angle. Oblique means joints which occur at an inclination, or joints which occur at an angle is called as oblique joints. Okay, so that is three things that occurs in a stratified rocks. Three joints that is occurring in a stratified rock, that is strike joints, dip joints, and oblique joints. Okay, so I will give the theory later. Now just understand from the picture. Okay, next one is a folded regions. In the folded regions, okay, so in the folded regions mainly you are having radial joints and C joints. Okay, so radial joints means what? Joints which is running parallel to the B axis. Sorry, you can see from this picture. This picture. See this one, a parallel joint and a C joint. Parallel joint, sorry, radial joint and a C joint. Okay, so here you can see that. Okay, so in parallel radial joint, joints running parallel to the B axis. Okay, joints which is running parallel to the B axis. So what do you mean by B axis? So from this picture you can see here, it is referred in this picture. This is a B axis. Okay, students. Okay, okay. So let's come back. I'm sorry for the interruption. Okay, so we're discussing about the classification of the joints. So classification of the joints. So here we have studied the classification of the rocks, classification of joints in stratified rocks. Next is in the folded region. So folded region means a rock that has been folded. Okay. So here mainly you are having radial joints and C joints. Okay. So radial joints. These are the joints which is parallel to the B axis. So B axis means what? See, radial means what? It will be like this. So this is basically radial. Okay. So B axis means this oblique axis. This one, this where it is. Okay. So see. So here you can see one oblique joints. Okay. So here this oblique joint will be having an oblique plane, oblique axis like this. Okay. So this axis is called as B axis. That means the axis which is at an inclination. Okay, the axis which is at inclination is called as B axis. Okay, so joints which are running parallel to this oblique. Okay, so here you can see this is the oblique joint. So oblique joints means it will be at an inclination. So this oblique joint, it will be having an oblique plane. Okay, so adinana you're calling it as a B axis. Okay, so joint which is running parallel to this B axis like this, it will be like this. Okay, joints which is running parallel to this B axis is called as radial joints, and joints which is running perpendicular to this B axis, okay, which is perpendicular to this B axis, it is called as C joints. Okay, so I'll show you one picture of this. See this picture. Okay, so this is a folded region. Okay, this is a folded plane. So here you can see this is a folded plane, and here this is a B axis. That is the plane along which the inclination has occurred. Okay, the plane along which the inclination has occurred. Okay, so this B axis. So if it is parallel, the joints are parallel to this B axis, it is called as a radial joints, and it is perpendicular to this one. This is the so you can see perpendicular to this B axis. This is called as C joints. Okay, so this is the B axis, that is along the inclination you are having the B axis. So here if this is parallel angle, it is radial joints, and if it is perpendicular to B axis, it is called as C joints. Okay, next one is mainly in the igneous and metamorphic rocks. We are having two types of joints again, that is cross joint and longitudinal joints. Okay, this cross joint is also called as Q joints, and longitudinal joints is also called as S joint. Okay, so this is mainly occurring in igneous rocks and sedimentary metamorphic rocks. Okay, so what happened to sedimentary rocks? Where is sedimentary rocks? Okay, so sedimentary rocks are basically stratified rocks that we have discussed here. Okay, sedimentary rock means basically they are stratified rocks. So the first case we have discussed about it. Okay, so now the remaining one is igneous rock, metamorphic rock. Okay, so here you can see. So here you can see the longitudinal joints and cross joint. Okay, so longitudinal joints, this is the longitudinal joints. That means joints which is occurring along the longitudinal direction of the rock. Okay, the rock which is occurring along the longitudinal direction is called as longitudinal joints അല്ലെങ്കിൽ S joints. Coming to the cross joint means joints which is occurring in the transverse direction. See here. Here, this is the joints. You can see the rocks joints which is occurring along the transverse direction. That is called as Q joints. Okay. So what it is mainly the igneous rocks and metamorphic rocks, we are having two types of joint, that is Q joints and S joints. S joints are not joints that is occurring along the longitudinal direction, along the lengthwise. That is S joints. And if the joint is occurring along the transverse direction, across the width, it is called as Q joints. Okay, so this is mainly occurring in the igneous rocks and metamorphic rocks. Sedimentary rocks occur ചെയ്യുന്ന joints ഏതൊക്കെയാണ്? Strike joints, deep joints and oblique joints. Okay, so sedimentary rock means they are stratified rocks. Next one classification is based on the genus. Okay, based on the genus. So here we are having three types of joint: tension joint, shear joints, compression joint. Okay, so from the name itself we can understand what are these three types of joints: tension, shear, compression. Okay, tension joint means the joints which is developed due to the tensile forces that is acting. Tensile force means what? Elongation force. This is the tensile force. Okay, tensile force. Because of the tensile force that is acting in the rocks, you are having tension joints. Shear joints means what? The joints which is occurring due to shearing forces. Shearing force means this is the shearing force, because of the shearing force. Next one is compression joint, because of the compressive forces. Okay, because of the compressive forces, you are having compression joint. Okay, so we'll see how these three types of joints look like. So here we can see tension joint. Here see, tension means what? Elongation, right? So here the elongation, because of this elongative force, we can say tension joint has occurred. Okay, the രണ്ട് ഭാഗത്തും പിടിച്ച് വലിക്കുന്ന പോലത്തെ ഒരു ഫോഴ്സ് ആണ്. Okay, because of this tension force, that is from two sides you are elongating. രണ്ട് ഭാഗത്തും പിടിച്ച് വലിക്കുകയാണ്. That is tensile force. Okay, so here you can see some joints has occurred. So that is tensile joint. Tensile joints. Next one is compressive joints. Compressive joints means what? Compression is occurring here. You can see ഈ ഉൾഭാഗത്ത് ഒരു ഞെരുക്കാണ്. Okay, inner portions you are having a compression forces. So here what is happening? This portion is elongating, but this inner side it is compressing. So here compression joints ഇങ്ങനെ ഒരുപാട് ഞെങ്ങി കഴിയുമ്പോൾ ഉണ്ടാവുന്ന ഫോഴ്സ്. Okay, like this. When you too much of compression, it will have this. See here, because of here the joints has occurred. That is compression joints. Next one is because of the shear, that is tangential movement. Okay, see here, because of the tangential movement, the joint has occurred over here. That is shear joints. Because of the tangential forces that is acting over the surface, you can see shear joints have occurred. Okay, so that's it. See, we can see one of the examples of the columnar jointed basalt that is occurred in Turkey. See this one of the joints that is occurred in the rocks. Okay, so this is columnar in structure. Next one is origin of the joints. How these joints are originating. Okay, so first one is basically, I don't know whether time will be there or not. Let's see. So the first reason how the joints are originating is by the contraction during the formation of the rocks. Okay, so how the joints are originating means, first reason for the origination of the rock is it might occur due to the contraction that is occurring in the formation of the rock. You can say, for example, igneous rocks. Okay, so the igneous rocks, the contraction occurs during the cooling process. That is igneous rock, how it is formed? The hot molten lava will be pushed to the surface of the earth. Okay, with the passage of the time, the magma will cool down. Okay, so while cooling, a contraction will occur inside the rock. Because of this contraction, the joints will occur. Okay, the same thing goes with sedimentary rocks also. Sedimentary rocks, you know how sedimentary rocks is formed. Like each and every sediments of materials are deposited on the rocks. Okay, that is by river, by wind, by air, or by any other agents. Sediments are deposited over the surface of the rock, and with the passage of time, it forms into sedimentary rocks. Okay, so during this drying process, a contraction will occur inside the rocks. Due to this contraction, again joints will be formed. So that is contraction. There is joints during the contraction. Okay, joints formed during the contraction. I think almost time now. You can pause your name to mark the attendance. Second one is due to expansion and contraction. Okay, we'll see you next class.